with section P.3, we'll talk a bit about parallel and perpendicular lines. First of all, notice that parallel lines must have the same slope. If you look at the picture, the reason for that is probably pretty obvious. We've defined slope as steepness, and we can certainly see that those parallel lines have exactly the same steepness. If they didn't, they would eventually cross and they wouldn't be parallel. So parallel lines have the same slope. Algebraically, we might say the slope of the first line, M1, has to be equal to the slope of the second line, M2. The relationship between the slopes of perpendicular lines is a little bit more complex. Clearly they're not the same, that they can't be or they'd be parallel. As I look at these two lines, they are perpendicular. In other words, there's a right angle. We often symbolize that with that little square in the corner. And mathematically, the relationship between the slopes of perpendicular lines is that they are opposite reciprocals of one another. Opposite refers to the sign. Reciprocal refers to really flipping the fraction upside down. We could write this by saying the slope of the second line, M2, is equal to the opposite, negative, and then the reciprocal, 1 over M1. One quick check to see that two perpendicular lines truly are perpendicular by looking at their slopes is you can either recognize that relationship, or sometimes people like to check this way. If I look at the slope of the first line, M1, and then I look at the slope of the second line, negative 1 over M1, what would happen if I multiplied those together? Well, the M1s would cancel, and I would get negative 1. So perpendicular lines always satisfy the property that if you multiply their slopes, you should get negative 1. All right, let's just practice finding slopes of parallel and perpendicular lines in the table. I'm going to tell you the slope of a line, and we're just going to write down the slope of first the parallel line and then the perpendicular line. If my original line has a slope of 4, the parallel line will also have a slope of 4. That's the easy one. The slope of the perpendicular line isn't very difficult either. We know it's going to be negative and then 1 over the original slope, so negative 1/4. In the second example, if the original line has a slope of negative 2/5, the parallel line will also have a slope of negative 2/5. And I'm actually going to use the space down below here just to illustrate the perpendicular. I know that I have to go with a negative and then 1 over the original slope. But remember that when you divide fractions, you multiply by the reciprocal. So negative, and then I go ahead and say 5 over negative 2. Negative negative makes that positive, 5/2. That's kind of running through all the math in a very formal way. But in all practicality, what we usually do is just say opposite sign makes it positive, and then the reciprocal literally flips the slope upside down. So we go with a positive and then 5 over 2. Again, we get the same answer, but I just wanted you one time to see the whole formal math of it. All right, let's take a look at a line with a slope of 0. The parallel line will also have a slope of 0. But what happens when you try to take the opposite reciprocal of 0? Well, we're going to run into trouble. As soon as I take the reciprocal of 0, I've got that 0 on the bottom of my fraction again, and I know that's undefined. So the slope of the perpendicular line is undefined. Hopefully that's not very surprising to you, because we just talked in the last section about the fact that a line with a slope of 0 is horizontal. And a line with an undefined slope is vertical. And if you think about a horizontal and a vertical line, they are certainly perpendicular. All right, the last one. If my original line has a slope of 1, then the parallel line also has a slope of 1. The perpendicular line, if I take the negative reciprocal, negative 1 over 1 is just going to be negative 1 for the slope of the perpendicular. We're going to go ahead now and use this idea of parallel and perpendicular and the fact that we can predict the slopes to go back and find equations of a couple of lines using some of the skills we developed in the first section. So, in this example, we want the equation of a line through the point 0, 5, and then parallel to the line 3x minus 4y equals 12. We're supposed to both find the equation of the line and then also graph both the given line and the one that we find. I'd like to start by just graphing this line. And there's a couple of ways I can go about this, but we've really been working with the y equals mx plus b form. So I'm going to go ahead and graph it using that idea. Right now my line is not in that form, so let's solve it for y to get it in that form. If I want to get y by itself, I'm going to have to subtract the 3x, which would make it a negative 3x when I get it over on the right, plus 12. And then I'm going to divide both sides by negative 4. Negative 3 divided by negative 4, I'll write that as a positive 3/4 x. And then 12 divided by negative 4 is negative 3. This is my original line. And we can certainly graph that right now. Our y-intercept down here is negative 3. And then our slope is 3/4. So we can just go up 3 and over 4. And I'll do that a couple of times so that I can draw my line. All right, now I'd like to start working with the parallel line. When we want the equation of a line, we always have to find m and find b. And in this case, finding m is going to be fairly straightforward. We know that parallel lines have the same slope. The slope of the original line was 3/4, and so I'm essentially just going to borrow that and say the slope of my parallel line will also be 3/4. As far as finding b, in this particular case, that's also fairly easy because we were given it, if you look back at the statement of the problem. The line we want is supposed to go through the point 0, 5. And 0, 5 right here is already on the y-axis, so I can simply use that b value of 5. And my parallel line will be y equals 3/4 x plus 5. We can graph that one as well. We already have the b value 5 plotted. And so if I go ahead and use my slope of 3/4, I go up 3 and over 4. I'm going to run out of space a little bit up here, but I can kind of estimate up 3 and over 4. Would be right about there. Or I could have also gone down and to the left, 3 and 4 this way, and that would also work. And there's my parallel line. One thing I haven't talked about yet is graphing equations and graphing lines, or really any other equation on your calculator. So let's just take a moment and do that. If you'd like to check to make sure you got an answer correct on your calculator, you can take a look at your lines. To do this, go into the y equals, and let's see, I'm going to clear out this other stuff that I had in here from before. And notice that you do need to have the y equals form to graph your line. And so I would have to have this y equals 3/4 x minus 3. As my original line. And then the 3/4 x plus 5. Whoops, and I missed a point. There we go. 3/4 x plus 5 as my second line. And now, if I simply want to hit graph, I'm going to get whatever window is already in there. If you want to set a custom window, you can hit this window button, and you can set whatever values you want for your window. The graph that we had here went from -10 to 10 on all the axes, or both axes rather, and so those might be convenient values to list from -10 to 10 with a scale of 1 tick mark every unit, and the same with y. And then I'll hit the graph button over here, and I can see my parallel lines. All right, let's try the perpendicular example, last one in this section. This time, I didn't give us the y-intercept, unfortunately. We'll have to work for that. We do know a point, though. We want our line to go through the point -1, 2, and be perpendicular to the line y equals 1/3 x plus 4. Let's start by graphing the original line. We would have a y-intercept of 4, and a slope of 1/3. So we'll go up 1 and over 3. And I'll do that a couple of times. Maybe down 1 and left 3. It's so easy when you're graphing with a ruler to get slightly off. So I like to plot a bunch of points if I can, just to get a nice accurate graph. All right, so there's my original line. Notice it definitely does not go through the point -1, 2. The point -1, 2 would be right here. And our line doesn't go through that point. So we want a new line that not only goes through that point, but is also perpendicular, or forms a right angle, with our original line. Anytime we want to find the equation of a line, we always need to find the slope and the y-intercept. So find M, find B. In this case, I'm going to use the perpendicularity to give me the slope of my new line. I know the original slope was positive 1/3. So to get the perpendicular line, I take the opposite reciprocal, negative, and then I'm going to flip that over, 3/1, or just the slope of -3. To find B, since it wasn't given this time, I'm going to use my standard y equals mx plus b, our slope-intercept form of the equation of a line. And I'm going to plug in some values. We just got an m of negative 3. Let's use the x and the y that were given so that we can plug all that information in and solve for the b. Y is 2, m is negative 3, and x is negative 1. Two would be 3 plus 1, or 3 plus b rather, and when I subtract the 3, I can see that I'm going to get a b value of negative 1. So the perpendicular line will be y equals negative 3x minus 1. We'll go ahead and graph that one as well. I'll start with the b equals negative 1, the y-intercept, down here. And then my slope, negative 3, I can go down 3 into the right one. And again, I'll do that a couple of times. Or remember, you can also think of this as a positive 3 over negative 1. So I could also go up 3 into the left one. Do that a couple of times as well. And I've got my perpendicular line. I'd like to take a look at those graphs on the calculator as well. When you look at the two lines that I just graphed, they do look reasonably perpendicular, at least on my paper. But let's take a look at what would happen if we were to graph these on our calculator. Clear out our last two lines here in our y equals menu. And let's put in the new ones. The original line was 1/3 x plus 4. And the one we think is perpendicular is negative 3x minus 1. I've already set my window to negative 10 to 10 on both axes, and until I change it, it will remain the same. So I can just go ahead and hit my graph button. And there's the original line, and there's the perpendicular line. You might notice that on the calculator, they don't exactly look perpendicular. It looked a lot better when you graphed it on your paper. The reason for that is that the spacing on the x and y axes on your calculator is not exactly the same. Notice how the x values are a little bit more spread out than the y values. That actually kind of skews the graph so you don't see the perpendicularity. If you really want to see the perpendicularity, go into your Zoom menu. There are a few kind of popular options here. The one that we're using right now is actually called Zoom Standard. It's option number 6. And when you want to get that negative 10 to 10 on both axes really fast, if you just hit number 6 for Zoom Standard, it'll give it to you right away. The one I'm interested in right now, however, is number 5, Zoom Square. What this does is it creates a setting so that the x and the y axes have the same size spacings. And if I go ahead and take option number 5 and just hit enter, notice this time when the calculator graphs, it looks a lot more perpendicular. All right, that's the end of the third section of our preview chapter, and we'll begin section 4 next time.